So here's my next attempt at creating a video to help you guys try some of these review problems. Again, it would be a good idea for you to try the problem out by yourself before you look at my solution. That way you're really getting into your own brain as to whether or not you understand how to solve these problems by yourself or not. And you can come back and watch the video and see how well you did. Let's continue here. This is number 43 from the Chapter 2 review. And we're given the graph of y equals f prime of x, roughly shown here. I tried to do my best to sketch it for you. And part A says on what intervals is f increasing or decreasing. Alright. So we should recall from the work that we've done in class, especially a lot lately, that f is increasing when, you'll have to excuse the poor writing sometimes, but you'll get used to it. F is increasing when its derivative, which is f prime of x, is greater than 0. Well, we're looking at the graph of f prime here, so we're looking for when the graph that we're looking at is above the x-axis, okay? So this intercept here, if you look in the book, is supposed to be at -2, the x-intercept right here. I sort of missed it a little bit now that I look at it. But nonetheless, we'll go by what the book has. And so from -2 up to 0, f prime is positive. Therefore, f would have to be increasing. Similarly, from 2 positive infinity, f prime is positive, so f would have to be increasing. So this occurs on, I'm just going to put this is on, this for economy of writing here. My S's don't want to come out too well. This is on. We use the word on for intervals here, so we said -2, 0, and from 2 to infinity. Now we never want to use a closed bracket on infinity, but whether or not we decide to use square brackets or parentheses at the numbered endpoints here is really irrelevant, because the AP examiners, again, only look at the number. They don't look at whether or not we're including or excluding the endpoint at the moment. Alright, similarly here, we're still answering the increasing or decreasing part, so we don't have a choice. We have to answer both, even though it says or. Mathematically, you still have to answer both. Okay. F is decreasing when f prime, the graph that we're looking at, is less than 0. Now, just as a side note to all of this, because we've used several different languages, not languages, but terms in order to determine what we're referring to, this graph is a function, and what we're answering the question about is the antiderivative of that graph. F prime is a function, the antiderivative of f prime is f, so we're still answering similar questions like the last example we did in our notes. We are trying to answer the question, when is the antiderivative of the graph shown increasing or decreasing? But we're using the language f prime and f instead of f and an antiderivative. But they're equivalent, so we should be comfortable in either setting. So f is decreasing when f prime is less than 0. And we can see from the graph in the book, and somewhat from what I have here, from -infinity to -2, and then from 0 to 2, f prime is below the x-axis, which means f prime is negative, and so this is occurring on those intervals. This is on, when I try to write too fast, I can't get that S before. This is on the interval from -infinity to -2, and from 0 to 2. The next question asks, at what values of x does f have a local maximum or minimum? So in this one here, we didn't talk about this directly in the class, but you were supposed to read about it, and it's in your book. It's on page 159, I believe. I'm turning the page back. Yes, it's on page 159, and you can go back and read what you might have missed or not read yet. So essentially, it works like this. Let me get a fresh page here for a moment. In considering the graph of a function f, okay, if f is increasing and then decreasing, where it transitions right here from increasing to decreasing, at this point right here, that's where we're going to have a local max. So again, f is increasing then decreasing. But if f is increasing, we know f prime over on this interval over here is positive. Okay, so f prime is greater than 0. And then over here, since f is decreasing, we know f prime is less than 0. And so, when we have the derivative, f prime, changing from positive to negative, we have a local max. Similarly, if we look at the graph of the function decreasing then increasing, like this, we can see that we're going to have a local minimum right here, because on this side over here, f prime is less than 0, f is decreasing, and on this side over here, f prime is greater than 0, f is increasing. So when f prime transitions from negative to positive, we'll have a local minimum. Okay? And I won't normally do this in class with the abbreviation L for local, but saves me some writing time here. So for our graph that we have in the previous, or in this example I should say, I have 3 points where the graph transitions from either being positive to negative or negative to positive. And those 3 points, we just now have to decide at each of those 3 points whether we have a local max or a local min. Alright, so at this x equals, again, this is going through at x equals negative 2 in the book, and I missed it a little. But around x equals negative 2, to the left, f prime is negative. To the right, f prime is positive. So f prime is changing from negative to positive, which means f is going downward and then upward around negative 2. We have a local minimum occurring at x equals negative 2. Similar argument would apply over here at x equals positive 2. F prime is negative right before x equals 2. F prime is positive right after x equals 2. And so the graph of f is decreasing, then increasing. And so we have another local minimum at x equals 2. So let me write that down here. F has, I shouldn't use the word here. I should use something more correct. We have 2, so local minima. The plural of minimum is minima. Min is ma. In Latin, the at the end is plural and is singular. So f has local minima at x equals negative 2 and positive 2 because f prime changes from negative to positive at these points. Okay, so we know where the local minima occur. We only have one other point at which f prime transitions from changes sign, and that's at the origin. To the right, to the left of the origin, f prime is positive. To the right of the origin, f prime is negative. So f is increasing, then decreasing around 0, and therefore we're going to have a local maximum at that point. So f as I can put a singular there. Now that looks absolutely terrible. Let me clean that up real quick. As a local maximum at x equals 0, because f prime changes, believe it or not, that says changes from positive to negative here. Alright, continuing on, let me get a fresh paper there. Part C says, where is f concave upward or downward? Okay, so recall f is CC up when f double prime is greater than 0. Well, we're looking at the graph in our example here of f prime. Okay, so f prime is, or f double prime, let's say it this way, f double prime is greater than 0 when we see f prime increasing. So, going back to the original graph here, where is f prime increasing? Well, f prime is going up from negative infinity up to 1, and again from 1 to positive infinity. So on those intervals, we have to have f concave upward. So again, I'm just going to say this occurs on negative infinity to 1, and I'm sorry, that should be a negative 1, shouldn't it? And then from 1 to positive infinity. Similarly, f is CC down when f double prime is less than 0. The second derivative is what tells us about concavity. And f double prime is less than 0 when f prime is decreasing. Guess I forgot the word is up there. So if we go back to the graph, we see that f prime is decreasing only from negative 1 to 1. And so that would be the only part where the graph is concave downward. So this is on negative 1 to 1. Alright, the only last thing we have is to sketch a graph of a possible graph of f. So let's get a clean sheet here. And let me draw some axes. Okay, so got those. I'll call that where 1 is. Call that where 2 is, and that looks terrible, but I'm a 15-minute time limit, and I don't have a clock going, so I have no idea if I'm running out of time or not. So I apologize if I'm doing this a little quickly, but we said that f was increasing between negative 2 and 0. Okay, so just between, switch to my pen here, negative 2 to 0, where the graph is increasing. So from here to here, and then again from 2 to infinity. Okay, so over here, so this way increasing as well, and that way. So the graph was decreasing from, we had 0 to 2, so let's stick that in here, decreasing, right there, and then again from negative infinity to negative 2. Let's go back and double check our answers from earlier. F is decreasing from negative 2 to 0 to 2, negative 2 to 0, and 2 to infinity. Alright. And then we also had concavity f was concave up from negative infinity to negative 1. So we'll get CC up here. And then from 1 to infinity. So we got CC up there. And then we got CC down in between. Alright. And they also said we have to go to the point 0, 0. So I got to make sure I include that in my graph as well. So there's my 0, 0. And now I just got to make sure that when I do all this stuff that we described up here, that I hit that point. Okay, so I need to be decreasing concave up for a while, and then increasing concave up, increasing concave down. So I want to make sure that I end up down over here somewhere, so I can increase concave down through that point. Okay, so I need decreasing and concave, decreasing concave up. Ooh, I misjudged my increasing. That might not be low enough. I'll have to make that work. So I need to be concave up and increasing, so I'll just kind of make a slight increase. And then increase concave down, and then I made it happen. Increasing concave down, kind of. Still concave down, and decreasing, so we're going to go back down this way. And then decreasing concave up here, and increasing concave up here. Kind of. Not the best picture, but still getting used to this pen, so I apologize. Hopefully you got the point. You can criticize me later and tell me how badly it looked, or how bad it looks.